Our esteemed speaker this evening has an extensively long history in the tech field and has spent the last decade as the CTO of Nuxeo. Decade, guys, 10 years at the same place as CTO of Nuxeo. Please welcome Thierry Delprat.
Okay, so thank you, Eric. Thank you for having me tonight. So tonight I'm gonna talk to you about Elasticsearch and MongoDB. Maybe there are already a lot of you using MongoDB or Elasticsearch, so maybe just so that I have an idea, who is using Elasticsearch right now? Okay, a few of you, and MongoDB. Okay, so the idea is to explain you how we use these two technologies to make our content repository scale, and give you some idea about how we integrated that inside the platform, what works, what does not, and what result we get from it. In terms of agenda, I will just start by a quick introduction, just explaining you basically who we are and what we are doing and what problem we want to address. Then explain you quickly why we moved from SQL to NoSQL technologies. Then I will give you an explanation about how we did technically the integration between our component, Elasticsearch, and MongoDB. And then I will give you some results in terms of what we get in terms of performance and how it works. So let's start with some context. So I work for Nuxeo. We are actually a small company. And what we do is we provide an open source platform that is focused on providing services and components that can be used to build content applications. It means that basically our target customer are people building themselves software. And we try to provide both the component but also the tool to assemble the component, to package, to deploy, including deploying in the cloud. And everything we do is open source. That's the way the company was created from the beginning, and that's the way we do software. So just to give you a brief idea about the kind of customer we have people like Electronic Arts that build an internal application to be able to manage who inside their organization has the right to download the game, test it, give feedback, and then pass to someone else. Basically, the idea was to be able to track who accessed the build so that they don't leak. So this is something they build using Nuxeo. So Nuxeo will then be used to store the game and manage the workflow and manage the way that people will have access to the game. We have a Jepsen company, a Boeing company that they basically sell fly bag. So the stuff the guy takes with him inside the plane to have information about where to land, about I guess the plan of the airplane and so on. And behind that there is a Nuxeo server that is used to distribute the content. And the last example I will give you is we have people doing product lifecycle management solution on top of Nuxeo. And actually what they store inside Nuxeo is recipe for food, so that they can have all ingredients for a given food product, including the history, so that in case of problem, they can go back and say, okay, at this moment, this product was manufactured this way using this ingredient. So basically the idea is that we have people using Nuxeo to build very different software and storing very different content inside the repository. So the main part of what we have is the content repository. So what we provide is a high-level API that completely abstracts what is behind. So basically we do a complete abstraction about the storage. And the idea is then that, well, you should be able to choose whatever storage you want without having a direct impact at the application level. So it means that we also provide a complete content model so that you can define what object you are managing, how these objects are linked together. Even if the backend ends up being schemaless, at least at the application level, we still have a model, because anyway, usually when you have an application and you have UI, you have a model. So it's good to know where is this model and have it managed and versioned as a software artifact. So that's what we do inside the platform. Then of course we will manage the security so that you can define who has access to what object inside the repository. We will manage versioning and history so that you know exactly what happens and you can go back in history, find the previous version, know who has modified the document and so on. we manage the life cycle so that you can define what are the different valid states for a content inside the repository and how you can move from one state to another. And the last point is we manage the blobs, because of course the document will have metadata, but usually they also have streams. So we will manage streams in a way that will make it work so that you can use big stream without having issues, and so that you can, for example, use CDN or stuff like that. So in terms of challenge we have to face, strangely enough, the biggest problem is not really the number of documents or the global volume. And maybe that's also because we are not really in the area of big data. But the main issue we have is queries, is having people that will build a lot of screens, and all these screens will create queries. So the first step that usually creates some scalability issue is the query part. Being able to query for data in an efficient way so that the UI remains responsive. Another use case that is kind of problematic is when people have to do a lot of write. So the typical use case is someone that will receive on the day-to-day big updates that need to be integrated inside the content repository as quickly as possible. So it could be, for example, if you store a lot of video, every day you receive changes about the right that have been changed on this video, so that you know you don't have the right to broadcast this video on this area. And this changes basically every day, and you have to inject it as quickly as possible. So that's one problematic use case. And the last one is, usually we manage stuff that are managed by human. So humans usually don't generate billions and billions of documents. But if at some point you need to track everything that has been done and create a new version every time someone changes something, then you may end up with actually billions of documents and a large audit log. And this can be a real storage issue, because usually you want to store, but you want also to be able to query and use it. So just to give you a quick history, so Eric said that I'm in Nuxeo for about 10 years, so I'm not very young. And we started a few years ago, and we were at this time using Python, and we are using Zopi, you said in English, I think. And well, the strange part is that at this point we were using the Z-object database, which was basically a Python object database that, well, the storage is pretty simple. You take the Python object, you serialize it, and you store it in a log file. So something that was quite strange, because at this moment, when we were installing Zope and ZDB in production, we had the Oracle guy on the side just looking at what we were doing and saying, okay, this guy is using something that stores serialized object into a log file. They must be crazy. And strangely enough, things change. And in some ways, it looks like some of the storage we are currently using. Of course, it was not that good at the moment in terms of performance. And at some point, we choose to move to something else. Basically, we rewrote everything using Java. And then at the beginning, we are using just Apache Jackrabbit, which is the reference implementation of a Java standard for content repository. It's a mix of SQL and Lucene. And since it was not complicated enough, we added another Lucene index to be able to manage more complex queries. So we ended up with a system that was quite interesting, but with a lot of transactional issue. So basically, we are trying to manage the Lucene index from within the transaction, and it was working quite good in unit testing. And then when in production under heavy load, at some point, well, we lost something, and we end up with deadlock at the file system level inside the Lucene index. So we thought, okay, maybe that's not the right solution. We should move everything to SQL. So that's what we did. We rewrote the repository completely on SQL. And actually, we have something that works very well, that is completely transactional and so on. But as we will see that just after, there are, of course, some limitations that are intrinsic to the fact that we are using SQL. There are some stuff that cannot easily be done with SQL. So a couple of years ago, we started looking for additional technology we want to include inside the platform to be able to address the use cases where SQL doesn't work as good as we would like. So that's where we started building something to integrate MongoDB and Elasticsearch inside Nuxeo, and that's basically what we will be talking about. So, I don't know if it's easy to see, but this is a global diagram about the repository itself. So on the top you have the document. So this is the object we will actually store inside the repository. So we have some attributes, we have the blobs, and the system will first separate the attributes and the blob. So the blob will go to a blob store, and the attribute will go to a separated storage. So at this point, the storage is called VCS, for Visible Content Store, and the idea is that we store this in a SQL database so that the database does make sense. So the idea is to avoid taking something like a Java serialized object or even JSON serialized object and store it like that into the database, but store it in a normal form, in a clean table, so that basically the statistic will make sense and the query will make sense at the database level. And in parallel, we have, of course, a query language that is called NXQL. And so we simply translate the NXQL to SQL so that we can do the query directly inside the database. And on the audit side, we just listen for all the events and we archive them in a database. So that's basically the whole SQL storage solution. Everything is XA compliant, so that if you want to use several different databases, you can do it. So that was the world we were in a few years ago. So it was working, but of course there are some real issues where we didn't find the solution. So the first point is that pretty much every screen will issue a lot of different queries. And the difficult part that we have to deal with is that we provide a framework, not a ready-to-run application, which means that the content model is defined by the user, the screen is defined by the user, so we have no idea about what attribute will be used, what the query will look like. So we provide tools so that people can assemble that, and they are happy. I mean, it's easy, you build your content, you build your form, that's okay, but behind that it creates quite complex query that then have to be translated to SQL, and this query can end up being quite complicated. And sometimes it's even not really possible to say that this query will work, because some query will just not be selective enough, and basically there is no way the SQL optimizer will find a good way to process the query. And in a lot of cases, we end up with doing DBA work about creating the right index and so on, but well, it takes time, and sometimes it's not easy to do. Another aspect is that even if you have done some optimization, at some point, if you do too many queries, well, your database server will be crash and download, and then you don't have a lot of solution. You can buy a bigger one. So that's a short-term solution, but there is no easy way to do scale out. There are solutions. What we tried didn't work that well and was complicated to handle with the fact that we want to do XA transaction and stuff like that. So, and the last point is that we were using the full text feature from the database, and most of them say they do it well, and actually when you try it for real, and you have multiple language to manage and stuff like that, that's a nightmare. And so that was the first reason for looking for other solutions. And then if you look deeper, what we have built is basically something that will do a mapping between object and tables. So obviously we end up with problem in terms of impedance issue, just because each time we store a document, actually we are storing 10 lines in the database. So this multiplication factor costs a lot at one time. And to avoid that, as probably everyone, we have a cache that will avoid eating the database too much, but this cache also has a cost. You have to invalidate it, you have to manage it. So that's an issue. And when there is anyway a lot of documents, we end up with billions of rows in the tables, and then it really becomes complicated to make it work, especially if you want then to be able to manage concurrency and still do a lot of update and insert inside the database. So that's the use cases that were problematic. So just to mitigate this a little bit, actually we have a lot of repository using pure SQL that works very well in production. It's just a question to know what you are actually doing with it. And the key point is that we don't know from the beginning exactly what people will do with it. So we want to be able to provide several options so that people can choose and eventually can even switch in terms of implementation depending on the use case they have. And one interesting point is that you can try to find what is the limit from moving to SQL, from SQL to NoSQL. There is also another aspect is that the kind of database you are using and the skills of the people that manage the database do matter in terms of performance. And sometimes it's far easier to say to people, you know what, your problem doesn't work because SQL is not the solution. You should move to NoSQL. It's usually easier than explaining them, maybe you should choose your database, you should change your database choice, or you should have people that know how to manage the database. At least we use that several times. So, the idea is that when we looked at the possible solution, we selected MongoDB and Elasticsearch. So basically two main open source products that works very well and that have a lot of people using it. So when using MongoDB, the key point is that we no longer have any impedance issue. So each time we will store or manage one document, it will be one simple document inside MongoDB, so it works very well, meaning we don't need anymore to manage the caching system. And in terms of scalability for every basic operation like create, update, delete, or even read the document, first, the performance are very good. And we have options for doing scale out that are at least simpler, not always very simple, but at least much simpler than what is possible using SQL database. And the last point is in terms of concurrency, especially when using the last storage engine from MongoDB, the fact that the locking is now managed at the document level makes that, okay, you can do a lot of concurrent update. As long as you are updating different documents, you won't have any global lock that will create issue. And this is something that was really hitting us when using SQL in some cases. So basically the idea was, okay, MongoDB should be a good candidate for doing the repository storage and the audit trail storage. Then when it came to the search part, we selected Elasticsearch. Basically the choice was quite simple because we were using, we had a long history with Lucene. Even with Python, we are using Lucene, so we are using Lucene indexes for quite a long time. We did at some point some tests with Solar. We are not that happy with it, so it really makes sense to quickly start with Elasticsearch, build a prototype, and as soon as we saw the result, we finished the work because it was very good. And the idea is that the system is very fast for both indexing and searching. The search options are very interesting, we will see that. And it's very good in terms of use cases where you write once and you read a lot of times. So it's very good for doing search. And it's also very good for doing the audit log, so storing all the events that occur inside the platform. So the idea was, okay, we have found the solution. So we just need to take the previous diagram where we had everything stored inside SQL. We unplug the SQL database and we create storage adapter, and we just choose, depending on the case, how we will work. So basically saying that, for example, at the document level, when we store the document structure, rather than hitting the SQL database, we will store it inside MongoDB. So that's easy to say. The idea is not to give you an idea about how we did that. So basically the first point is that the lower building blocks, the one that is just before the storage adapter, we used to have something, well, we still have something that is called VCS that does the mapping into a SQL database. And then we built a new one that is used to be able to store the document using JSON. So the idea is quite simple. We have a storage in memory that will manage all that. And then we have a second level storage adapter that will write the data into MongoDB. So the default ID is that the Nuxeo document itself can be configured. So everything inside it is completely dynamic and depending on the configuration. But let's say out of the box, you have a document that has about 40 fields. And we store everything inside the same JSON document, inside a single collection. And you can configure how many attributes you nest. So you can create complex structure, it will create subdocument, and so on. So everything will be stored like that. And since internally we need to be able to issue query against MongoDB, we have to create some indexes so that, for example, we're able to manage the parent-children relationship or stuff like that. And the files themselves, they will just be reference. So here we have some examples. It's not easy to say, but to see that you have a structure where you will have file, and the file will actually be just digest, and then the digest will be used to go take the stream from the binary store. So then, once we have this stored inside MongoDB, we now have to manage the parent-children relationship, because what we manage is actually a hierarchical database, so we need to be able to manage that. So we simply have a parent ID attribute inside each of the document, and then because we need to be able to manage query on path, we have additional attributes that are computed by the framework about listing all the ancestors of each document, and we use that to be able to do direct queries on this. So all this is computed and maintained by the framework, so each time you move something, there will be an asynchronous task that will compute that on all the subchildren. And another aspect we need to manage is the security. So we have a descriptor that is used to express the security concern. So saying what user can access, can do what on the document, meaning, for example, you can read, you can write, you can delete it, and so on. And it's quite easy to be able to store this information and verify it on a per document basis. It's a little bit more complicated to be able to do that when you are doing search. So the idea is that we compute a read ACL for access control list, that will list all the principal and users that have access in read to this document, and that's what we will use to be able to do a search. So initially, inside the framework, inside the application framework, the query is written in an SQL, and then we translate it into a language that the backend will understand. So when the backend is MongoDB, we will simply add a filter on this read ACL part that will be maintained by the framework itself, so that it's always up to date. And we do the same thing whether you are issuing the query against the SQL database, against MongoDB, or against Elasticsearch. That's one query that gets translated in different query languages, and each time we try to maintain the right attributes inside the different storage so that we can do the search in an efficient way. MongoDB by itself only manages transactions on a per document basis. So it's good because in most of the case, user will just modify one document. And the fact that we don't have a real transaction is not so bad, because we need it when you are using SQL database, because one document will be multiple rows. So we need something to make that more secure. When we are using a JSON document, that's not so much of an issue. So it works. And one case that is not covered is when you need to update a lot of documents altogether, but actually even when doing SQL, usually we don't manage long transaction on hundreds of documents, because using a long transaction doesn't work. So this part is not so bad, but still, there are cases that are problematic in terms of application layer. There are a lot of cases where what we do is actually modifying multiple documents from within a single user action. And for that, the typical use case is you are validating a workflow. The workflow will do some modification on several documents, And this is typically a case where you want it to succeed or fail, but you don't want to end up just in the middle, because it doesn't make any sense from the application point of view. And another aspect is that with MongoDB, since you're updating documents and only them are updated atomically, people may see stuff that you are currently doing. So there is no real isolation between what people are doing. So we try to limit the problem of this by building on top of MongoDB a system that will manage everything in memory, saying, okay, from within the transaction, what we will actually do is store and record every event that has been made. So you are creating a document, then you are updating the document, or you are deleting a document, and we store all that in memory. And then we wait for the global commit, because there is still a transaction manager, because we may have additional data sources that are connected, and we still want to have a global transaction. And we wait for the end of this transaction to flush that to MongoDB. Of course, it doesn't always work like that. One of the key problems we have is sometimes in your code you do some changes, and then just after that you issue a query. And for being able to run the query, basically you need the data to be in the database. Otherwise you have to replicate pretty much everything in terms of query system in your in-memory storage. So what we do, we accept the trade-off, and in case there is a query, we flush the data to the database to be able to issue the query against the real backend. So, but still we maintain a complete undo log, which means that we don't have a complete isolation, but we are able to roll back a complete transaction. So we're able to undo completely something. So at least we recover a commit rollback paradigm, which means that, okay, you do a new step in the workflow. If it fails, then it can roll back, and it can roll back properly. And it's, in our case, it's very important because a lot of people are building workflow, and they can assemble building blocks, and they can decide themselves to say, okay, I want to roll back this. So it has to work. So it's not perfect, but it works good enough for a lot of use cases, and we have a lot of benefit coming from the fact that we are using MongoDB, so the trade-off is quite interesting. When it comes to Elasticsearch, the idea is that we didn't want to integrate this as a primary index. We have the index that is inside the repository, the one that will be updated in a synchronous way, and we have the secondary index that will be provided by Elasticsearch. This one may be asynchronous, and at the query level we handle some routing, which means that when we receive a query, depending on the configuration, we will choose whether we send it to the repository itself or to the Elasticsearch index. So the changes in terms of implementation are handling security, so I already talked a little bit about that. The idea is always the same. Post-filtering just doesn't work in terms of scaling. And in addition, one of the great features of Elasticsearch is the ability to compute aggregate. So if you are getting from Elasticsearch entries that have not been filtered, basically all your aggregate are wrong. So it's not useful anymore. So we use the same principle. We compute a read ACL that we index, and we join this at low level inside the query. Actually, we don't join, we just add a filter clause because we did some testing with using join, and it was not so successful. Then the other challenge was to be able to keep in sync the Elasticsearch index and the repository itself. Because we have, on one way, we have the repository that is updated synchronously, then we have the index, and the risk is that at some point you lose something. And it's very bad in terms of management, because you then have documents that appear in the index that are not inside the repository, or the reverse. And actually that's something we had in previous implementation where I'm trying to synchronize the repository and Lucene. So we try to do it in a very different way, accepting the fact that, okay, we don't want the Lucene index to be part of the transaction. We accept the fact that it will be asynchronous, and we'll do it in a slightly different way. And for that, we do something that looks like a little bit what we do with MongoDB. Actually, we record everything that happens inside the transaction. And all that is stored in a thread local. We may end up deduplicating even, because, for example, you may create and update 3 times a document. So anyway, what you want to do is a creation inside the index. And then, at the end of the transaction, when we have everything, we deduplicate all the events, and we send them to Elasticsearch with a bulk update. And the key point is that, of course, since this is asynchronous, there is always a risk that you shut down the system during the processing of this asynchronous task. So inside Nuxeo, we use a queue for managing all the events, as this queue is backed by Redis that itself is configured with a persistence log. So the idea is that everything we create in terms of job for updating the index may not be processed immediately, but we cannot lose it. So eventually, we will end up with the index and the repository that are up to date, because the job will be retried. So even if Elasticsearch at some point is not available, the job is persistent, it will be automatically retried. So at some point, the index will be in sync with the repository. There is still one case that is problematic, is that inside Elasticsearch there are a lot of different optimization to make it really fast. And well, this comes with the fact that there may be at some point a difference between what is indexed, what is searchable, and what is actually persisted on disk. And we don't want to flush all the time to disk because it will kill the performance. And I think it's not what is advised by people from Elasticsearch anyway. So what we did is we say, okay, the cases that are problematic are the case where it's driven by the UI. So if as a user I'm looking at the list of documents and I do something on the document and this action should make the document disappear from the index, then I want to be sure that the document won't be displayed. Because, I mean, as an engineer, usually people understand that, okay, that's because it's asynchronous and so on. Well, the user doesn't really care. I mean, I just validated the task, I don't want to see the task anymore. So we have to provide a way to make it work, and ideally we want to make it quite magic so that it works without people having to think of, including the people that are building the app. So what we do is simply we flag the current transaction with something that says, okay, this is a UX transaction. This one is driven by the UI. And then automatically the collector of event will run in a different mode that will say, okay, at the end of the transaction, I will directly flush and ask for a refresh at the index level. And actually it works very well because the way user update the document through the UI is actually very small in terms of the number of updates you have because of batch processing, complex workflows, and stuff like that. So here again, the trade-off is quite good. Another part of the storage is where we store blobs. So this is something very simple. We just store a stream, and we want to be able to get it back. The metadata about the stream is actually stored inside MongoDB or inside SQL. And we provide several storage for that. So it could be a file system, it could be S3, it could be GridFS on MongoDB, it could even be Google Drive, because it provides some nice feature like the Google document integration. And when you are storing on S3, you can then use the CloudFront CDN to download your blob. So you have some additional gain from that. And the system that will do the storage is completely abstracted so that you can put in the middle something that we call a blob dispatcher, so that depending on the attribute and some rules you can define, we will choose the right storage for that. And anyway, most of this storage will provide a way to deduplicate the blob and provide a way to do the snapshotting so that you can back up the global application without losing some data. And the last storage part is the part where we store everything that happens inside the application. So everything about all the events. So of course there is some configuration about what event do you want to record and what do you want to do when an event occurs. It could be create version and so on. And that was clearly an issue when using a SQL backend. So we just provide a MongoDB backend and an Elasticsearch backend so that we can store everything inside it, and then it works very well. So the idea is that we end up with several kinds of storage, and we can mix them together. And then it's really up to the choice of your application to define, okay, what do I want to use? What kind of warranty do I want to have from the backend storage I'm using? So I would like to talk a little bit about what are the choices that can be made, and in what case using what storage makes sense, at least from the point of view of a content repository and from the use case we have. So I think that each solution can make sense. It really depends on what are the constraints. And I mean, a SQL database, if it's correctly managed and configured, it can work very well. You have a lot of security on that. You have strong schema, and the only drawback will be to be able to make it scale up to what you actually need. With MongoDB, we have very good CRUD performances, a little bit less warranty in terms of transaction management, but as we just saw, in most of the case, we are able to handle that in a way that make it harmless from the application point of view. And Elasticsearch is very good for handling very complex query in a very fast and scalable way. So that's what we will actually see in terms of ideally, initially when we built the Nuxeo Elasticsearch plugin, it was a plugin, something that was optional. And one of the questions we had is, okay, in what case do we want to say people use that? So for that, the only way we know is, okay, let's do some benchmarking. So quite early, we started doing some tests, and based on our past where we sometimes had issue with, okay, the index is not completely up to date, you need to reindex the database. Okay, we need to be sure that we can do it very fast. So these are some benchmarks. Most of them were actually done on the CI chain, so on one of the Jenkins slave that run the bench on the day-to-day basis. It's about reindexing a full repository. So we are able to run at more than 3,000 documents per second when using a SQL database. And the interesting part is that actually Elasticsearch is not the bottleneck. Because if we change the backend and we switch from SQL to MongoDB, then we're able to reindex the full content at 10,000 documents per second, which means, okay, if you have several hundreds of billions of documents, it will take some time, of course. But still, in most of the case, it's fast enough so that you can say, okay, in the worst case, we will be able to recover. It won't take 3 months. We also did very quickly, well, it was one of this diagram here are stuff that were taken from the integration chain. So it's about something that does benchmark on queries. And we were just doing a diff between two results, one result with a SQL database and one result with Elasticsearch for doing the queries. So what we see is that when we are using Elasticsearch, basically you can inject load and you can add more queries, and you get a response time that is always the same. And the more you inject load, the more response you get, which is exactly what you want, usually. And we also did some scale-out tests, so it's not really rocket science. I mean, when you know the way it's built, you know that obviously if you add more nodes, you will get more queries per second. It's still good to be able to validate that quite easily and verify that, okay, if I'm able on this node to handle 3,000 requests per second, if I add a new one, then I'm able to do the double. And so we did that. We are happy with this result. And the fact that we can choose between the secondary and the primary index makes that actually we don't have any bad side effect. meaning your code can decide, or the configuration of the application can decide. In most of the case, the only drawback you have with Elasticsearch is that the index may be a little bit behind the repository. Usually it's not visible. There are only some edge cases where it can be visible, and most of these edge cases are actually inside your code. So it's inside business code that will do something and just want to get a query and wants the result right now. And usually your code don't really care about doing aggregate or full text search or stuff like that. It's a very basic query. So this basic query can go to Elasticsearch, to MongoDB or to the SQL database. It will work. The query that is challenging is the one done by the user on a complex screen, and this one can go to Elasticsearch because even if the index is a few milliseconds behind, actually the user won't see the differences in most of the cases. And because Elasticsearch also stores the JSON document directly inside the index, that's the default configuration and that's the one we use, we are also able to read from Elasticsearch, which means that we can completely offload both the search and the read, which means that basically the database is not loaded anymore. And this one is actually some kind of translation of a Jira ticket. So the software is open source, so we provide training, support, and so on. Because at some point it's good to pay the developers. So and a lot of people use the support to ask questions about sizing, about how to deploy, and so on. And so we had a customer that was actually doing a CMIS benchmark. So he was deploying a Nuxeo and issuing a lot of CMIS query against the server. And he was worried because he was saying, okay, I use quite a large database server, but basically I'm stuck. I have 400 queries per second, and I cannot do more because the database server is 100% CPU, so, and I cannot really buy a bigger one. So he was asking, what can I do? And they were just about to upgrade to the new version, so we just said, okay, just activate the Elasticsearch plugin. And so the guy come back to us saying, okay, no, I'm running 1,200 requests per second, but I don't understand, the database does nothing, Nuxeo does nothing. Where is the bottleneck? So actually the bottleneck was the network, because he was just sending too much query for the network. So just fixing the network bring them to about 2,000 query per second, which means that it's just a game changer. Meaning when people have issue in terms of query, and once again, in a lot of cases, the limitation comes from the number of queries you inject inside the system, at least for the use cases we meet the most often. Having this ability is just magic. And actually, even internally for the solution architect working on the product, at some point they were just saying, okay, every time you have a problem, you just say Elasticsearch and it will solve the issue. It's not always that simple, but basically the idea is that we were thinking about, okay, should we make that optional inside Nuxeo or not? We tried. We didn't find any real drawback of this because it just provides more options, more features. So, well, we put it by default in 6.0, so it's still the case in the next release that will be out in probably 2 weeks. So it's now by default inside Nuxeo. We have one index inside the repository and one Elasticsearch index on top of that. In addition, it provides a lot of nice features in terms of aggregation, statistics, and stuff like that. So it's great. In terms of use cases for MongoDB, basically the idea is that it really makes the difference when you have a lot of data. As I was saying, not everyone has a lot of data, at least not in the kind of use cases we are addressing. But as soon as people start asking for, okay, I would like to be able to track every changes, then they will generate actually a lot of documents. And we have a lot of people that say, okay, I would like to be able to track every changes on all the next years. So maybe I would like to keep 10 years of history of all the changes that have been done to all the documents. So at the beginning, it's okay, but a few years later, then it's a huge amount of documents. And the other cases that may be problematic are the ones that are write intensive, for people doing everyday daily import and update. And in this case, we did some benchmark because we know basically what are the use cases that were problematic using SQL. So we just reproduce this and test it against MongoDB to see, okay, everyone says it's supposed to scale and work. Okay, let's verify that. So we did a very simple benchmark. It's about taking a Nuxeo server, then a server where we install both a SQL database and Mongo. So we test only with one at a time, of course. We inject continuous read, and then we start injecting the same amount of query for writing, for updating stuff. And then we look at the global throughput of the system, and we look at the way we are able to inject write operation. And what we see very clearly is that the SQL database crashes, meaning the throughput globally doesn't increase, and we have a very hard time injecting the write operation because they are blocked by the read operation. And doing the exact same thing using MongoDB, well, it just works. Of course, there is some side effect of doing read and write at the same time, but still we are able to inject the write operation very quickly, which means that for people that have to do a daily import, well, the daily import is smaller, so you can pass it quickly, and then you can resume the normal operation of the system. Another type of benchmark we did is about injecting content inside the repository, so we have tools for doing that. And when taking the same kind of machine, so we took quite small machine, so just VM you can take on Amazon, and just inject document inside it. What we see is that with the SQL database, we are able to go quite fast until we reach the point where basically the index doesn't fit anymore in memory. And when each index, each insert will actually trigger automatically access on the disk, and then it's finished. The throughput just drops. When doing this with MongoDB, what we see is that the throughput is almost flat, which means we're able to inject. On this graph, it's 30 million, but we have done tests against 70 million with the same speed, and it's completely flat. And the last use cases that is very problematic with SQL is basically when people are rendering a content tree that is complex. So you have a lot of objects that are all tied together, and you do something with them, you process them. And when reading this document, you will go from one document to another. You will read some properties. Because these objects are tied to a SQL database, it will trigger lazy loading. It will fetch additional data from the SQL database, and you will end up with a lot of back and forth between your code and the database. And that's the use cases we have, for example, with people doing rendering of a very complex insurance contract with a lot of sub-objects. And it was taking a lot of time, and the strange part is that it was taking time, but the CPU was not used, the database was not used. We're just spending too much time back and forth between the code and the database. And just moving to something that will be able to fetch the document at once, just change completely the performance. And we did a very simple benchmark about getting a big tree of documents and processing it. And basically, when using MongoDB, we are about 15 times faster than the same code running on SQL. So, some example of that, we have customers providing VOD, video on demand services. So they need to store a lot of videos. They need to be able to manage all the metadata about the video because they need to display that with who are the characters in the video, what is the rating of the video, and so on. They have to manage workflows in terms of, okay, I have to validate the fact that I want this to be accessible, and so on. And they also want to generate different rendering and thumbnail of the video, and so on. So they choose to build that on top of Nuxeo. And one of the problems they have is that they have a lot of metadata because it looks like there are a lot of standards of metadata in the video world. So they have to store all that. And they have daily update. So every day they have to receive the changes in terms of write about this movie is not available anymore if you live in California, stuff like that. And they also want to track all the changes. So it's basically some kind of compilation of all the use cases that are problematic when using a SQL database. So that's why they basically choose MongoDB. And one interesting point is that they were also very keen on moving to NoSQL. Looks like part of the team had bad experience with SQL, bad experience with proprietary software, so basically they wanted to do NoSQL and open source. So we do NoSQL, we're open source, so we work together. Another use case is that is pretty much about mixing all the different building blocks. We have some people, a typical use case is people working in press agency, where people have to write news very quickly. So there is a lot of concurrent work on doing an article, reviewing the article, validating the article, and all this needs to be completely safe. So they want to have a SQL database for that. But then they need to also keep the whole history. And so what we do is we keep the part that is warm into a SQL database, because the part where people are working on is actually not that big, because they just need to keep all the news they are doing for 1 month. So that's actually a small number of documents. So it could even fit in a memory database. And then they have all the history that is inside MongoDB. And then we have a global index that is inside Elasticsearch, so that they can still access the data and completely transparently. And we can basically provide the best of both solutions. And that's a way to use each storage for what it can provide and choose exactly what you need. So just to give you an idea about what we plan to add to this, of course, both Elasticsearch and MongoDB are releasing new versions, so we of course have some work to align on that. One interesting point that we have into the MongoDB API is the possibility to have batch processing on the large amount of entries. So our goal is to make an abstraction on top of that, so that we can have a high-level API inside the framework, so that people can leverage that without having to actually depend on what is inside the database, so that we can provide, once again, different implementation of the same feature depending on the actual constraint and environment. Another feature we plan to leverage is the percolator inside Elasticsearch, just the ability to, let's say, index the query you have, so that you can be notified when a new document will match a query. That for our use case, for managing the notification for the users, or managing the update to the Drive client that synchronizes part of the repository, that's a very nice feature. And we already have some customers that ask us to build additional backend for the storage adapter we built for storing the document inside MongoDB, because we have one complete abstraction and then a small storage adapter for MongoDB. And we have people that, we have internally people that want to absolutely test Postgres plus JSON just to see what it gives in terms of performance. And we have customers asking for example, a Cassandra backend. So, that's part of what will hopefully happen in the next month. And that's it.
Before we move on to Q&A, just want to give a great round of applause to you. We are going to give away this beautiful Apple Watch very shortly. This bowl is filling up, but everybody has to have a chance to put their card in. So Pat, I'm going to pass this around one more time, and please put your business cards in there. If you don't have a business card, by all means, make one out of any piece of paper you find and drop it in there. We'll put complete information, email and everything, please. And let's take the first question. Hans?
What's the process for, like, if one of your clients already has a system, like a CRM or anything like that. It's a process for taking all of their data and then putting it into your framework. Because you mentioned at the end that that building APIs is something for the future.
We have an API.
Oh, so they, okay. So
Yeah. I mean, everything we do is exposed using REST API. But when it's about importing data into the system, we have a low-level Java API that does that, and we have a pipeline for importing data using XML, for example, or JSON. And we have a framework for doing that in a multi-threaded way, so that you can import on different queues in parallel. So that's something we do usually when people migrate from one existing system to Nuxeo. Of course, we have building blocks for being able to do that. It's about providing the infrastructure for doing multi-threaded import. So managing correctly the transaction, the transformation of the data, and so on. Usually it requires some tweaking because obviously you don't know exactly what you have at the beginning, so you have to translate the data.
Yeah, that's why I was asking, because it almost feels like it could be anything, right? It could be from something legacy or any type of old database.
Usually what happens is that in a lot of cases either we are replacing a document solution, or people are building a completely new application, and in that case we will have some data import to initialize some part, but we don't have a full I mean, when we were doing the backend for the electronic feedback, there were no application doing that before. When we did that for electronic arts, there were no application before. So
that's good.
But still, we have the case about replacing stuff like document tools. So we have stuff for getting the data, transforming the data, crunching the data, and putting that into Nuxeo.
Next question?
Yeah.
I'm a Django developer, and this looks like an awesome thing that could potentially be dropped right in and just abstract away all the things that I thought I was going to have to think about really soon, which would be great. How easy is it for like a Rails or Django developer to just drop this in and use an existing ORM with a framework like that? Is there an interface there?
So everything we do is exposed via REST API.
Right.
So we have a way to expose all the content. You can search for the content, modify, do workflow, anything through the REST API. And the REST API will expose the data that have been configured. So you can configure the data structure we have. You can do it by hand in XML if you want. We have a service online that allows to build the configuration. Basically, you define your object that you want to store, and it will generate the configuration. And from your application, you just use the REST API. So,
but in terms of like integrating, like it might already exist, but like you know, an installable that does that for you, takes your ORM from whatever your framework is and translates it to those REST calls. Do those exist yet?
We don't have that right now.
Not yet. Sure.
We have clients in different languages, but we have a way to expose business adapters on top of all the REST API. So people usually use that when they're migrating for an existing system, and they used to have an API with different objects. And basically, we rebuild the whole system, and we just re-expose the same object, doing the mapping on the client side.
Next question?
So basically, so you don't work with ORM, right? I mean, you build your own ORM. You don't integrate with anything. It's not that.
Well, the very first step we did, we tested a little bit with Hibernate, and we were just not happy with what we get. So we built. So the SQL part is the SQL implementation is a way. Well, it's a kind of ORM that we built by ourselves. The MongoDB part is not.
Okay. The actual question. So you integrated with Elasticsearch,
yeah.
And Elasticsearch's eventual consistency. There's no immediate consistency whatsoever.
Yeah.
Your client's okay with that?
Yeah,
That to me, that means that your use cases are pretty limited to only to the customer who don't care about you know, any time frame. I mean, there's no any definite time frame that Elasticsearch will give you results.
So that's why we keep the two indexes, and we are able to configure on the per screen and per query basis which queries will be sent to the repository that will be synchronous, and which query will be sent to Elasticsearch. And basically, if you are doing a big faceted search on 10 million documents, you won't see whether or not the index is a few milliseconds or a few seconds behind. If you are working on a list of documents and you are modifying a document, and then you want it to appear with the new state, then maybe you prefer use the SQL implementation. And that's, we maintain both, and that's just configuration. And we can do it on a per screen basis.
I agree that you will not see that, but you basically will not know. You will not know at any point of time whether your item will be, you know, included in the result set or not, because that Elasticsearch index may be not reaching it.
Well,
so there's no any there's no any consistency with that.
Unless the Elasticsearch cluster is down, and then we need to be restarted. At some point, it will get the data.
At some point, but I mean, I understand what's happening. I mean, you have messages inserted into your system, and then from some other, you know, side, somebody is querying your system.
Yeah.
So that query may not, you know, may not give results of the items that are already there for a very long time, just because of the Elasticsearch.
We've never seen more than a few seconds behind in the use case we have, and we have benchmarked. And the other point is that you're right, in some use cases, you cannot even accept the fact that it's 1 or 2 seconds behind. And in that case, you just configure the query to go to the repository. It really depends on the use cases. And there are a lot of cases where it's perfectly acceptable to be a little bit behind.
But then in that case, if you don't have the secondary indexes from Elasticsearch, you don't have any indexes. So we
have the indexes in the SQL database.
In the SQL database, yes, but in MongoDB you don't.
In MongoDB, we can configure them. We have also configuration for doing that. So of course, that's always the same trade-off. Meaning, you can configure a few indexes in SQL or in MongoDB. You cannot configure 200 indexes and expect it to work. So that's where Elasticsearch is really better, because you can basically query on any attribute, it will work. When you are addressing the SQL database or MongoDB, you have to tune the database for these queries. And we create default indexes in both SQL and MongoDB for the query we need to manage internally. But then it's really up to the configuration. I mean, if you are configuring and if you are storing invoices and you want to do search on the invoice number, then, well, you will have to tell Nuxeo, okay, I want this field to be indexed. And then Nuxeo will create the index.
Okay. Next question? Yeah, in the back.
Yeah, I was wondering if you're providing analytics to your clients as well, and what are your thoughts on using Elasticsearch to provide analytics?
So actually, it has been a long storing document into a repository. At some point, you want to have analytics about, okay, what is going on inside out. And what we have done is we are actually using Elasticsearch for providing dashboards and analytics on that. Since we index the whole document repository into Elasticsearch, and since we put, this is also configuration, but it's by default, we put all the audit log into Elasticsearch, we're able to do queries on that and to build dashboard on that. The only missing point that we had is, okay, there are a lot of HTML and JavaScript components that can do queries on Elasticsearch. The only point that was missing is the security. And of course, we don't want to expose anything without having security, because anyway, the data will be false, and it could be a real security issue. So what we do, we re-expose the HTTP API of Elasticsearch on top of one of our components that then does the pass-through to Elasticsearch, just adding the security filtering. So it's about doing some kind of an alias on top of several indexes and adding the security filtering. We have to look, because I think that this is part of, there are some features like that in the new version, I think. But
so I had a similar question about the security. So you said ACLs are maintained on top of Elasticsearch and MongoDB.
Yeah.
and that's not part of either of them. In other words, you're not using the ACL of MongoDB.
No.
So is that also exposed via REST API or not?
Yeah. Yeah, the idea is that, of course, everything that is processed will be scanned by the security system. So basically, you cannot access the data without going through the security service. So that's what you expect, meaning you cannot access the data through the UI, through the REST API, or through the Java API without going through this. And we exposed also the REST API for managing the ACL. But the REST API are at the content model level. So you are managing the fact that you have one document and you want John to have this permission on this document. Knowing
how
how
about
we
Blob? Blob also gets under the umbrella of the same ACLM.
Yeah.
Is there a case where you use just Elasticsearch and not the MongoDB, like you mentioned before?
Sorry? Can you repeat?
You had a use case where, or you had a storage option where you used only Elasticsearch and not MongoDB, right?
This is part of the question we are currently asking to us internally, whether we try to use Elasticsearch as a primary backend. Technically, it seems feasible. For some reason, I still find this strange, but because, well, at least in my mind, this is an index. But after all, it does storage. It works very well. It just seems a little bit strange to
Have you
me.
pulled out MongoDB and does it work? I mean, I'm not talking about performance or anything like that. Does it work as is or not?
Sorry?
If you pulled out the MongoDB, right? You already had the repository inside Elastic, right?
Well, we have most of the information inside Elastic, and we are able to read from within Elastic. And actually, in the use cases, I was talking about offloading the read. Actually, you can continue the bench and shut down the database and continue running.
That's what I said.
But it's also an option. So we do it at the query level. You decide whether you are sending the query to Elasticsearch or to the repository. And then you have another flag that says whether you want to fetch the data from Elasticsearch or from the repository. Because fetching the data from the repository can also be interesting in terms of, okay, I'm sure that then I will get an additional post-filtering in terms of security in case the Elasticsearch index was behind in terms of security. So once again, there is always a trade-off in terms of, do you want to go as fast as possible, or do you want to have data that is more up-to-date? So in most of the use cases, we don't have that much issue in terms of Elasticsearch being behind because, well, it works quite well. It's quite fast, and but still, the problem exists. So we provide a way to choose.
Okay. Yes.
So we see it's basically a content repository primarily. Are you using it for other things as well, like storing personal information, things like that?
Storing?
Personal sort of information.
Wow.
Anything sort of like that.
I mean, a document is a definition that is pretty abstract. So anything you can define as a JSON object can be stored and indexed and queried and put in a workflow, managed in terms of security. So we have people that are storing recipe of strawberry pies inside Nuxeo, and that was not the intended purpose. It just happened that, okay, it makes sense, it works for them, it's good. So we have a project that's called Nuxeo IDM, where we provide a structure to store organization, person, groups, permission at a high level, because we had this requirement for one project. And okay, we had to store some entities, manage relationship between them, manage form to update them. Okay, we have something that does that, so we use it. And actually, it's a Nuxeo plugin that does an IDM, so manage people, organization, and so on top of Nuxeo. That was not the initial use case, but well, that works all the same. So
Sure,
it's basically a document without Blob, and well, it doesn't make sense. In a lot of cases, you just want to store properties. You don't need Blob. For people, maybe you need a Blob for their picture or I don't know.
Sure. We have time for just last one. Yeah.
Question about Elasticsearch. You shard your data, and have you had issues with any split brain type, and you take snapshots? How do you recover?
we don't host the solution. So we just provide the building blocks. So we had discussion with several clients depending on the way they want to host the different building blocks. By ourselves, we host a cluster, and so far we cannot have any issue, and we are hosting that on Amazon with the, we couldn't use the EC2 discovery because we are using Docker container on top of that, so it adds a little bit to the complexity of the system. Usually we say exactly the same thing for Elasticsearch than someone that will ask us a complex question about the configuration of their Oracle rack cluster. Well, we are just the guy providing the building blocks. We can help you defining the global architecture in terms of Nuxeo, but if you want very specific advice about how to better use Elasticsearch, probably you should go see the people building Elasticsearch. That's their job, and they are better than us to do that. It doesn't mean that we try to stay in the loop and learn in the process, and we have actually done that a lot on several databases and so on, but we already have a lot of stuff to manage. So,
last question of the evening. Let's have one more. Yes.
Okay. Say project and use cases where MongoDB fits perfect. What are some good reasons why I would use Elasticsearch?
sorry?
What are some good reasons?
The main reason is the capacity to do queries. So it's really about how many attributes you have and how much you know about exactly what people will do in terms of query. I mean, that's always the same thing. If you have 10 attributes and you know that you will only have to answer to 5 different queries, maybe you can do it with fixed indexing. And say, okay, I can store it into MongoDB, it will work very well. The problem is more, if you end up with 200 attributes per object and the user start building their own search screen, because then it's an issue, because you cannot index everything. So that's where having an external index that is just dedicated to that does really the difference.
Okay, we are going to give away this Apple Watch right now, but before we do, can I please have a great big round of applause for Thierry? Where is the fish bowl with the, may I ask you to just reach in and mix it up?
That one.
Okay, and in that case, since you know which one it is, may I ask you to put your hand and look the other way? Reach out. She's going to be shaking her own. No, you got to put it out. I got to pick one out. And read it out loud. Angel Moreno? Right here. Congratulations. Thank you all for coming today. We'll be here for one-on-one questions. Feel free to come up right now and ask.